So in chapter 3, we're looking at numerically summarizing data. So with today, we're going to learn some new things, and we're going to add them on to what we were talking about in chapter 2. Okay, so the first thing I want to talk about are the different measures of central tendency. So I brought this up last class. This is what I'm talking about here is the center or the typical value. So here I'm going to look at measuring the center of a distribution. My typical value. And this is only for numerical data. Okay, so we can't do this for the categorical data. Remember I mentioned to you that we would kind of put categorical data on hold for a little bit, and this is where it's starting. Okay, so for the measure of central tendency, we have 3 ways of measuring this. In the 3 different ways, we're going to start with the mean. All the mean is the average. We have a couple notations. So this Greek letter mu is the population mean. So this is the average of whatever, maybe average age, if that's what we're studying. So because it's numerical data. So it's the average of an entire group, not just a sample. So it's the population mean. And we also have X bar. So X bar, let me write that in parentheses so you know how to say it. You go back to your notes. X bar is my sample mean. Now it's just a notation difference here for this because the calculation for these two are exactly the same. You're just finding the average. So here for the population mean, you're going to add up all of the data values. So it's the sum of xi divided by n. And capital N is just my number of data values. So I'm just going to write that over here. So that is for my population. I'll write it out in just a second. And then for the sample mean, it's the same calculation. No, that's worse. Okay. My sample mean, and this is the sum of all my data values. So sum of xi divided by lowercase n. So up here I'm going to write it. So n or lowercase n is just the number of data values. So it's the number of individuals in your sample, or if it's uppercase N, of your population, okay? But the calculation's the same. It's just the average. You're going to add them all up and divide by however many you have. Okay, so when we're looking at the mean, this is what we call maybe the center of gravity. We use when the data is quantitative, right? So numerical, the distribution is roughly symmetric. Okay, so let me write that down. We use this when it's symmetric. And remember, I'm gonna say roughly symmetric because nothing is perfect, so it's not always exactly symmetric. Okay. so that's the first way of measuring our center, the mean. Let me just move some of this around. Try to continue here a little bit. All right, so the second one we're going to look at is called the median. And the median is exactly the middle point, or the middle value. So the way we calculate the median, first of all, it's super simple. If you have a small data set, you could just look to see what number's in the middle. But sometimes it's not that easy. Sometimes we have a lot going on. We have a lot of data values, and it's not just that easy to say, oh, it's the one right in the middle, and to find that. So I have a couple different ways. So first, if n, so remember what n is, n up here is the number of data values. So if the number of data values is odd, so if you have 99 data values, is what I'm talking about, okay, an odd number of data values, then the median, and I want to write this over here, capital M is my notation for median, although I don't really use it that often. If I want to say median, I just write it out. If n is odd, then the median is equal to the value in the n plus 1 divided by 2 position. Now I want you to understand, it's not n plus 1 divided by 2, it's the value in that position, okay? Because sometimes the value actually works out so it seems similar to the data value, so that we think it's just that number, and it's not. So that's if n is odd. Okay? N is odd. The other scenario is if n is even. Then in that case, then maybe we have n is equal to like 100, okay? Then what we're looking at here is the average of the two middle values. So you're looking at the average of n divided by 2 and n divided by 2 plus 1. Those two numbers, you're going to take the average of those. I'm going to write position because it's the numbers in those positions. Okay. So what this does is the median is very helpful for us because the median divides our data set in half. Okay. So we have half above the median and half below the median. And as we keep moving forward, this is going to mean a lot to us. So let me just write this down. So the median divides the data in half. Okay. Again, numerical data, and we usually use this when we have a distribution that is skewed left or right. Okay. All right. And the last measure of central tendency is one we've already talked about. This is the one we talked about last class, and this is my mode. But I still like to include it in this class, even though we know that it's the one that occurs the most. It's the most frequent data values. And we just use that one, not necessarily when we want to know the center now, because now that we have these two, these are better. But we truly use the mode when we just want to know which one occurs the most. So that we kind of don't use the mode a ton. So we used it last class, we'll use it on the assignment. And if we just want to truly know which one occurs the most, that's when we're going to use it. But if we're asked to find a center, we're going to use either the mean or the median going forward. Any questions so far on those? All right. So let's take a look at an example. So we're going to look at an example and we'll we'll find all three, the mean, median, and mode. So the example I have is the number of goals made by a soccer team during 8 games. So I'm going to give you the raw data. Right, this is the raw data I collected from 8 games from a particular soccer team, okay? So the first thing I want to do is I'm going to say, well, let's find the mean, median, and mode for this data, okay? So just to start right off the bat, I didn't say if it's a sample, right? Or if it's all the games that soccer team played, maybe that year. So maybe it might be a population, so I don't know. So I'm just gonna move forward and I'm going to just use the notation for the mean as just, and I didn't write this down before, as mu, which is my Greek letter right here, mu, sorry. I'm gonna write that down on the notes here. So we have that. I'll write it right in front of it. That's MU, you pronounce it mu. Then that way when I scan the notes in, we have it. There. Okay, so I'm gonna use that, which remember is all the data values divided up, or added up, sorry, and then divided by the total number of data values. So here it's just this simple, right? And then divide by 8. So here I have 14 divided by 8 and I have 1.75. Okay, so that's the average, right? So the average number of goals is 1.75. Okay, so let's take a look at the median. So here I'm going to look at capital M for median, and I'm going to pull up this again so we can see. So when we're looking at this, I need to know if N is odd or even, right? So we know there's 8, so N is even, okay? So in that case, I'm going to take the average of the 2 middle data values. In order to do that, I need to rewrite all my data values in order. So I'm going to start with the smallest, and I'm going to work my way up to the largest. So for my median, I'm going to start here, and I'm going to put commas in between so I don't think it's like 11 or something like that. So I'm just going to reorder these, and this is crucial for the median. Okay. I'm just going to make a little note. N is even. Okay, so I'm going to take the average, N divided by 2, and N divided by 2 plus 1 positions. Okay. So here I'm going to look at N is 8, so I'm going to write it right below it. 8 divided by 2 and 8 divided by 2 plus 1. So I'm going to take the 4th and 5th position. So I'm going to write it like that, 4th and 5th positions. It's not 4 and 5 that I'm taking the average of, it's the 4th and 5th. So 1, 2, 3, 4 is going to be 1, and 5 will be 2. So I'm going to add the 2 of those and divide by 2 to have my average. So up here for the mean, I got 1.75. For the median, I got 1.5. And they should be normally pretty similar if it's a symmetric distribution. Okay. All right, and I'm going to squeeze the mode in here because it's a simple one. There's not much going on with that. So for the mode, again, it's just whichever one occurs the most. Sorry, my phone is ringing. I forget when I'm here to put that on silent. So whichever one's occurring the most, and we can see right here, it's 1. So the mode is just equal to 1. Okay, so those are my 3 different measures of central tendency for this data set. Are there any questions on finding any of these at all? Okay, no questions. Okay, so I do want to mention we use the mean a lot going forward. And we can use our calculators or Minitab or whatever technology we chose to calculate that for us. I see the question, sorry. There could be more than one mode, right? There can be more than one mode. It's just we don't in this case. We just have the 1. Yep. So if maybe 2 occurred 3 times, then I would say I have 2 modes, 1 and 2. Yep. So this has a single mode. Okay. So let's move on to the next topic in chapter 3 that we're going to look at. So the next one is called the, what's 4th and 5th used for again? 4th and 5th data value. So I'm going to take the 4th and 5th data value, 1, 2, 3, 4 is 1. And the 5th is number 2, and I'm going to average those. Yep. Okay. So the next thing we're going to talk about is called the measure of dispersion or the measure of spread. Okay. So when we were looking at the first one, that was our measure of central tendency, that was our center. Now we're going to look at the spread. So if you think back to last class, I said when you describe a distribution, we're going to use the center, the spread, and the shape. And this is what we're looking at. So we already talked about the center, and now we're going to look at the spread. So again, we're looking at here how to measure the variation within a data set. So that's what the spread does. It measures the variation, meaning just how close are the data values to one another. Are they spread out? Are they clumped? And we kind of talked about this a little bit last class in my video. So again, we have 3 ways here. So we have 3 ways to measure spread. And I'm going to start with the easy one first, and that is called range. We already looked at this last class, and we don't use this too much, but once in a while we do. And the range is just my largest data value minus the smallest data value. Okay, and that is my range. The next one is called standard deviation. We use standard deviation a lot. Standard deviation is just the average distance from the mean. So you'll see when I show you this calculation, it's a long one. We do it once or twice, and then you'll use your technology going forward on that. But all it is it's just calculating how far away the data values are from the center. So from the average, from the mean. So it's that average distance, all the data values are from the mean, okay? So let me show you some notation first, and then we'll get into the calculation. So for the population, it looks like this, and this is our Greek letter sigma. This is my population standard deviation. I'm going to abbreviate standard deviation. And S is just my sample standard deviation. Now, this is not like the mean, where it doesn't matter if it's a sample or population, you do the same calculations, just the notation's different. It is not like that. This actually has a slightly different calculation here for my sample standard deviation. So I'm going to show them both to you, and then we'll try it out here in a few minutes. So sigma is actually equal to the square root of the summation of my data values minus the mean. Here's that distance from the mean squared divided by all the number of data values, however many data values I have. Let me just write this over here. Xi, those are my data values. Mu, just to refresh your memory, my population mean. Okay. And S, it's almost the same calculation, slightly different, is the square root, and it's the summation, again, of all my data values, but I'm looking at the distance from X bar because it's the sample, so the sample mean squared, divided by the number in my sample minus 1. So again, here, my Xi is the same. Let me just write N up here. I'll write it as population size. And then X bar, sample mean, and lowercase n is sample size. So I'm not going to get into this a lot about the difference between the two just yet. We will a little bit later on, but n-1 is called degrees of freedom. And I'm just going to write it down so at least you see it. So n-1 is called degrees of freedom. And we'll talk about it a little bit more going forward. But the reason why we use n-1 here is because we're actually using X bar up here. And because we're using a sample mean, then we have to use n-1. And like I said, I'm going to get into it more a little bit later on in the semester when it means a little bit more to us. But I just wanted to point that out, that we use n-1, and it's because of this guy right here. We got to place the blame on something to make our calculation a little different. Okay. So when we calculate the standard deviation, we're going to make a chart. We'll go through it. I'll make the whole chart for you. I'm not going to write down the steps because we'll do it once now. You're going to do it once with your team, and then that's it. You will use your technology going forward with it. So, but we will make a little chart. I just want to show you the last way of measuring spread, and then we'll do an example. So the last way of measuring spread is called the variance. And for the variance, we really don't use this often, but the variance is just going to be my sigma squared. I can try. There you go, a little bit. So our variance is our sigma squared, or we can use S squared. So our variance is our population standard deviation squared, or it's the sample standard deviation squared. And we don't use this often because the measurement is in squared units. And if something's in squared units, it's really hard to talk about it, about something that's not in squared units. It doesn't really make sense. So in our class, we don't really use it that often, but I still like to show it because it does come up. It won't really come up much in our class. You may see it on your homework a little bit, but I just like to mention it. So I'm just gonna write this down. So since this measure is squared, it is difficult to interpret. Okay. And I'll put or just use. It's just difficult to use. Okay. All right, so let's take a look at an example, and hopefully we can get a better idea of what's going on with standard deviation. Okay. So in this example, I took a look at last semester, the number of questions answered wrong on exam 1. Okay, and here I have a sample of 9 students. So right here in this example, I'm telling you I'm looking at a sample, and right there, that tells you that you're gonna use S, this calculation here, which we almost always use because we rarely study an entire population. Okay. All right, so I'm gonna make the table. I'm going to just show you the table with the data values. Like I'm not gonna just write them out horizontally. I'm gonna start filling in the table. So the first part of the table here, I'm going to put all my data values. That's my X. So I had someone miss 1. I had a couple people miss 2. I had a few people miss 3. A couple people miss 4 questions, and someone missed 5 questions. Okay. Now, in my next column in my table, I'm going to write down my X bar. So X bar is the average of all of these. Okay, I'm going to tell you it's 3. I know it's 3. I've already calculated it. So it's, I'm just going to do 3 like that. Okay. And my next column is going to be sorry, I was just trying to read in the chat, make sure no one had a question. My next column is going to be the subtraction of these two. So it'll be X minus X bar. So that's giving me this right here, the Xi minus X bar. Okay. So I have 1 minus 3, so -2, and then I have -1, -1, 0, 0, 0. I'm subtracting it from 3, right? Or 3 from that data value, sorry. 1, 1, 2. Okay. So my next column, I'm going to take each of these values and square them. The reason why you have to do this is because if you added all these up, it's just the distance from the mean, and the mean is the average of all those numbers, it will add up to 0, right? So this column right here would add right up to 0, so you need to square them. That's why we have to do that. I'm just gonna fill that in real quick, okay? So now I'm going to add this up. So this is, keep pulling this one back in here, the summation of them being squared right here. So it's gonna be my whole numerator right here, okay? So I have 12. Okay, that is my table that I fill out. If I'm to do this by hand, I never do this by hand because I have technology to do it for me, so I don't need to do it by hand. And the same for you. Like I said, you will do it. It's not even a full one by hand with your group. It's like a partial. But I like you to see it. It means more about the calculation and what's going on. Okay, So now that I have my numerator, so that is 12 divided by n minus 1. So we have a sample of 9. So divided by n minus 1, I'm just going to write it out, is going to be 12 divided by 8. Because n is my sample size, and that is 9. So here I get 1.5, right? But s is equal to the square root of this number. So s is my sample standard deviation is equal to 1.2247 in this calculation. So 1.2247 represents the average distance from the mean. So what I'm saying are all these data values are on average 1.22 standard deviations away from 3. Okay, that's what that's saying. Okay. When you work with your teams, you're going to have a chance to look at this using your technology as well. So make sure when you work on team assignment number 3, you have something ready, a calculator, Minitab, Jump, whatever you're choosing to use, make sure you have that available because you will start using it for this right away. Okay. All right, so I have one more thing before we're done with this, and that's the shape. So like I mentioned, for looking at distribution and describing it, we talk about shape, center, and spread. And for, yes, I do leave it as the exact value. Yep, so the question was, do we leave the value as exact? Yes, we do. Nope, we do not round. The only time, like on an exam or like on your homework, that you are gonna round it because you don't want to write 10 decimal places out, right? I will normally tell you 2 decimal places on an exam, and then specifically maybe some questions I want 4 decimal places. On team assignment, I'm not really picky, but I would stick to something around 2 or 4 decimal places. I wouldn't just round like to 1. I would not do that. Of course, the more decimal places you use in a calculation going forward when we use the sample standard deviation, the more accurate your values are going off of that. So just keep that in mind. So if you use like 1.2, it's not incorrect. It's just if you use S later on for something else, and I used 1.2247, my number is going to be more accurate than yours would be. Okay, that's all it comes down to. So on like an exam or something, I will say round to 2 or round to 4 decimal places. On the homework, it will also tell you. Okay, that's a good question. Thank you. They're all good questions. Thank you. So the last thing I want to look at is the shape. So we talked about this a little bit last class, so we don't have a lot to discuss, but there's a little bit more to it now. Now that we have a measure of spread and a measure of center, we can go a little bit further with the shape. So remember last class, I talked about the 3 different shapes that we're going to consider. And the first one is symmetric. And for symmetric shape, what you're looking at is something, I'm trying to think how I want to draw this. I'm going to draw it as a curve instead of just the bars for the histogram. So this is a symmetric shape. And the symmetric shape, this is also called bell. So I'm gonna write this up here. You may hear it called bell-shaped, which is fine. When we're looking at this, the center here is going to be both my median and my mean. I'm going to use the population. So in this case, we look at the mean is equal to the median. I'm going to write it out since the notation is new for us. Okay, so the mean and the median are normally right in the middle for a symmetric distribution. And they are pretty close. Keep in mind, our data is real world data that we use. So it's not going to be perfect. So realistically, if you're looking at a problem, even in your group or homework, anything, your median and your mean probably aren't going to be exact. So it's not exactly the same. They're not exactly equal. They're fairly similar. Okay. So stats is like a lot different than something like calculus or algebra, because if we say something's equal in algebra, we mean equal, right? We mean 3 equals 3. We don't mean 2.9 equals 3. In stats, it's a little different. You have some wiggle room, okay? So just keep that in mind. All right, the next one we're going to look at is skewed right. I'm going to try to fit this all on here. So skewed right. So remember my skewed right, I'm not the best at drawing these. You're going to go up and then it comes back down. You have a trail to the right. It's not the best drawing. But I want you to see that the median is still in the middle of the distribution, but now the mean has changed. It's no longer in the middle. The mean gets pulled with the skew. So the mean actually gets pulled to the right with all of these skews. So in this case, my mean is to the right, so that means it's greater than my median. Okay. And we have just the opposite for our skewed left. I want to squeeze it in here. My skewed left here. I'm awful at drawing skewed left, to be honest. So my skewed left, or my attempt to draw a skewed left, my median is in the middle of my data set, but then my mean gets pulled down. So try to think of it as if you take a whole bunch of quizzes in a class and you keep bombing quizzes, right? You keep getting lower grades down here, your average gets pulled down. Or the other way around, if you keep getting really good grades, it will eventually get pulled back up. So here, the mean is to the left. That means it's less than. So the mean is less than the median. Right there it is. Okay, so those are the shapes. So we took the shapes we talked about last class, and we're taking it a step further with using the mean and median. So when we do this, we can actually look at numbers. So we can look at the mean and the median and see what the shape is from the numbers. We don't have to actually look at a histogram or look at some sort of curve. We can know the shape based on just the numbers. All right. Any questions on this information from Chapter 3? No questions? All right, let me stop this